everyone. Welcome back to Vyas Data Talks. In this video, we'll build an intelligent weather dashboard using LangChain, Tavily Search, and Streamlit. Our app lets users enter any city name. For example, I enter Hyderabad and click on Get Weather. Behind the scenes, a React agent powered by Google Gemini 2.5 fetches real-time weather data and displays it in a Streamlit application. So the weather in Hyderabad is the conditions are mixed. Temperature is around 26.1 degrees Celsius. Feels like 27.7 degrees Celsius. Humidity is around 74%. So this is our Streamlit application where the user can enter city name and a React agent fetches all this information and displays it. So now let's deep dive into the code and see what it takes to create a React agent. This is our Visual Studio code. On the left-hand side, under the Explorer tab, you see we have a folder called agent. And under agent, we have multiple files. The first file is a .env file, which contains all the API key related information. For example, your Google Gemini API key, your Tavily Search API key, all those information are stored under the .env file. Next is the requirements.txt file. This contains information regarding all the necessary libraries that we require to create a first agent. Then we have a final.py file, which contains all the code for creating a Streamlit UI, our tool, and a React agent. First, we start by importing our required libraries. We use Streamlit for creating our web interface, .env for loading the environment variables, and all the other LangChain and LangGraph components which are required for building our agents. Next, we load our .env file using the load_.env function. We extract the Google API key for Gemini 2.5 and Tavily API key for our search. If either of the key is missing, we display an error message saying that please set Google API key and Tavily API key in your .env file and stop the execution so that we don't accidentally run without having the credentials. Next, we initialize our large language model. We are using Chat Google Generative AI from LangChain's Google Gemini integration. Here we set our model to Gemini 2.5 Flash, which is optimized for speed and efficiency, and use a temperature of 0, meaning our outputs are consistent and deterministic. This model forms the brain of a React agent, capable of reasoning and choosing when to use tools. Now we set up Tavily Search using our API key. Tavily is a powerful real-time search API that returns concise, structured web results. In this app, we'll use Tavily to fetch live weather information for any city that the user enters in the Streamlit UI. This is where we create our LangChain tool. We define a function called getWeather and decorate it with @tool, which is used by a React agent to call this particular function. It takes city name as an input, forms a search query, for example, weather in Paris, weather in Hyderabad, or weather in New Delhi, and then calls the Tavily API to fetch the results. Once we get the results, we extract useful information such as the city, country, temperature in Celsius, temperature in Fahrenheit, the wind in miles per hour, the wind speed in kilometers per hour, the humidity, what is the local time, what is the feels like temperature in Celsius and Fahrenheit. If anything goes wrong, say Tavily doesn't return structured data, we handle it with an error response saying that no weather information found for this particular city. This function is what the React agent will actually call behind the scenes to get the live data. To ensure clean, structured responses, we define a weather schema class using Pydantic. It defines the exact fields our model should return, like city, region, temperature, conditions, and humidity. Then we create a Pydantic output parser using the schema. This parser forces the agent to output only valid JSON that matches our expected format, which helps prevent random text or formatting errors. Now comes the cool part. We create a React agent using LangGraph's create React agent functionality. React stands for reason plus act. The agent first reasons about what to do, then acts by calling the right tool. We pass in our Gemini model, which we had stored in LLM, and we also pass our getWeather tool. Then we also have a prompt which says that you are a helpful assistant use the getWeather tool to fetch real-time weather and only return in the JSON format in the following schema. Basically, using the schema which we had defined previously using Pydantic. This combination makes the model act like an intelligent orchestrator, deciding when to call the API and how to interpret the results. Next, we set up the Streamlit interface. We define the page layout, title, and description using the setPageConfig and ht.title. So for the page title, we have kept it as live weather dashboard. For title, live weather dashboard. And in the markdown, enter a city name to fetch the current weather. Then we add a text box where the user can enter a city name and a button called Get Weather. This makes our app simple and interactive. No command line needed, just type a city and click. When the user clicks on Get Weather, we first check if the user has entered anything or not. If yes, we show a loading spinner while the agent runs. We send the user message to the agent. For example, what is the weather in the city? The agent then triggers the getWeather tool, retrieves live data from Tavily, and formats into a JSON. We parse the model response using our Pydantic parser. If something fails, maybe due to JSON formatting, we show a clean error message instead of breaking the app. Finally, we display the weather results in a clean and responsive layout. We use two columns, column 1 and column 2, one for the weather icon and one for the text details. The app shows conditions like sunny or cloudy, temperature in both Celsius and Fahrenheit, feels like temperature in both Celsius and Fahrenheit, wind speed in miles per hour and kilometers per hour, humidity, and even the local time of the city. This creates a modern, visually pleasing weather dashboard powered by AI. And that's it. We have built a complete React agent using LangChain, Gemini, and Tavily, all running inside a Streamlit interface. This app takes natural language input, reasons about what to do, calls the Tavily tool to fetch live data, and renders everything in real time. You can easily extend this setup, for example, adding more tools to get news, stock updates, or even flight information. If you found this walkthrough helpful, hit the like button, share it with a friend, and subscribe for more LangChain and AI agent tutorials. Thank you for watching and see you in the next one.